This is Module 2, Question 5. This is a really complicated question, so we're going to take it one piece at a time. You are helping some defensive lineman negotiate a salary, and this is his current salary, and he wants to change it. So he wants a $10 million signing bonus, but he wants the contract value to increase by $3.5 million. He wants an equal salary paid every 3 months, with the first check 3 months from now. So essentially he wants an annuity that's 6 years long but paid quarterly. If the discount rate is 5.7% compounded daily, what is the amount of his quarterly check assumed 365 days in a year? Okay, so the first step is to make the interest rate into the different periods that we need, because this is an annual contract, so we're going to need the annual rate. We're also going to need the quarterly rate because he is getting payments every 3 months or quarterly. Okay, so let's get the interest rate, 5.7%, 0.057. This is the daily, compounded daily. Let me move that. Okay, so to get the daily rate, we divide by 365. To get the annual rate, we do 1 plus the daily rate to the power of 365. So the daily rate's compounded 365 times to get the annual rate. And to get the quarterly rate, oh, and I have to subtract 1 to make them look all the same. To get the quarterly rate, we can do 1 plus that, the annual rate, to the power of 1 divided by 4 minus 1. Notice there's another way to do this. You can do it, you can take the daily rate, well, it's going to be 1 plus that, to the power of 365 divided by 4. So it's the same thing as pulling the annual rate and raising it to the 1/4 power, but you can do it this way too, and we get the same answer. So let's forget that this ever existed. I'm going to make it black, because when they give you something like that, you want to completely forget that this is what you want. Annual rate used for annual calculations, quarterly used for quarterly, daily, in fact, we can forget as well. Okay, 0, 1, 2, 3, 4, 5, 6. Let's look at the value of the cash flow. 7.9 and 4.3. I don't think that's right. Let's put it in accounting. $4.9 and 5.7. $6.7 and 7.3. $8.4 million. Alright, so what's the present value of this? Equals that divided by 1 plus the annual rate, I'm going to lock that, to the power of the year. Why did we use the annual rate? Because it's in annual terms, and that's how we get the cash flows back. We're going to sum these to get the net present value. So this is the cash flow, this is the present value of the cash flow, and this is the net present value of the contract. That would be all fine and dandy, but the new contract, he wants to be worth 3.5 million more. So he wants a new contract of 47 million. And the shape of this is that at time 0, he wants a bonus payment, well, a signing bonus of 10 million. And then he wants an annuity that pays every 3 months, and let's just put out here annuity payment. And for now we're going to do a placeholder. So $1 million is the annuity payment that he wants, and this contract NPV is going to be the sum of the annuity and the signing bonus. We don't know what this annuity is yet. We know that we want the contract NPV to equal to this because that's what the question told us. He wants the contract value to increase by 3.5 million, so that plus 3.5 million is 41 million, and we want our new contract NPV to equal that. So we're going to do equals present value. Our rate is the quarterly rate. He gets a payment every quarter, so it's 4 times 6 because he has a 6-year contract. We're going to put a negative because Excel does that weird thing with the negatives where it spits out the wrong number. And we're going to select $1 million. We don't have to worry about the future value or the type. We just close the parentheses and hit enter. So let's make that easier to read. Your contract value with $1 million payment is 30 million. Now you can guess on this and change that to 2 million. And you get, that's too high, 50 million is too high, or we can just use goal seek. We are going to set cell C16, which is our contract NPV, equal to, and I don't think you can actually click this, you have to write it in, $41,429,061 by changing the annuity payment. Hit OK. It's going to calculate it. Hit OK to close it. And you end up with 1.5 million. Which is exactly the answer that he gets on his solutions as well.